All right, good afternoon to those of you in person here in Science Student Union and those of you who are joining us on Zoom. My name is Bradley Flam. I'm the director of the Office of Sustainability here at Westchester University. And I'm very glad to welcome you to this, the 8th presentation in our Spring 2024 Sustainability Research and Practice Seminar. Every Wednesday from noon to 12:50, we have an amazing group of faculty members, students, and staff who talk about their work, their research, their professional practice at Westchester University that supports the university's environmental, social, and economic sustainability commitments. So we're very glad you're here today. We do have, if we're in the 8th and we've got 12, we've got 4 more presentations. For those of you who are here in person, we have copies of the program up front. Please take one before you go. And for those of you joining us online, you can find a copy of the program at the Office of Sustainability's homepage at wcupa.edu/sustainability. So thank you for joining us. And without further ado, I would like to pass the podium to Professor Rainear. Thank you.
Thanks everybody for attending. I appreciate it. I'm going to be talking today about a research project that's currently in progress that I received some RACA funding for in the College of Arts and Humanities Research and Creative Activities funding. And I hope to be launching data collection soon, either towards the end of the summer, or hopefully by the beginning of next semester. The project is titled Coo-Coo for CoCoRaHS, participation in a nationwide meteorology citizen science program. At Rainear, I'm in the Department of Communication and Media. I just want to start with a little bit of background for those of you who don't know who I am, because seeing somebody talk so heavily about meteorology and weather in a Department of Communication and Media is kind of rare. Weather communication and weather social science as a field is relatively novel and new and kind of rare in itself, but I think the individuals who take place in these roles are also fairly rare. So I am an assistant professor of media and culture in the department. I have a Bachelor of Science in Meteorology and a Bachelor of Arts in Journalism. So when I started in my undergraduate career for the first 2.5, 3 years, I really wanted to be a TV meteorologist. I did the campus television studios. I did all the internships. I interned at CBS 3 Philadelphia for a while. And what happened while I was an undergraduate was Hurricane Sandy. And so in my junior year at Rutgers, Hurricane Sandy obviously was a very impactful storm. We lost school for an entire week, which in itself is just kind of unfathomable to think about. It was such a crazy disaster affecting your state, your home state there in New Jersey. And so I really just pivoted entirely in what I wanted to do. I cared less about being a TV meteorologist and wanted to really investigate and understand, like, why don't people listen when somebody tells you to evacuate, tells you the water is going to be 10 feet high right outside of your door. And so that became more interesting of a question for me. So more about risk communication, a little less about science communication, but they really do blur together very well. I'm from the area. I was born and raised in Salem County. I went to Rutgers before I left for UConn. So I'm a big Jersey guy, for better or for worse. My first weather event I can remember when I was a kid was Hurricane Floyd. I think it was 1999. We lost 2 days of school for that, a tropical storm. So I got to play video games as like this little second grader. And I was like, don't really comprehend what's going on, but it's fun, it's exciting, it's cool. And one of the first things that just sticks out in my mind about weather, obviously the most impactful has to be Sandy. Up until Sandy, it was always Hurricane Katrina. For whatever reason, I just found the idea of New Orleans as a city and being in the vulnerable location it is, and then getting Category 4 or 5 hurricane affecting it. That was just kind of crazy to me, and it really was my first like science media infatuation. And I love tropical systems, as you can see, and also snowstorms, blizzards are my favorite. Today, I'm just going to talk a little about why I think citizen science is really important, really powerful. I'm sure most of the people in this room would agree. Why we need it and how it helps us in society engage with the public and bring the public into the participation of the practice of science. I'll talk a little bit about what CoCoRaHS is, because I'm sure most people aren't familiar about what it is, but it is very similar to a lot of other citizen science projects you may be familiar with, you may participate in or engage with in yourself. And then I'll just talk a little about my planned study, which is pretty much completed through the literature review. IRB is almost ready to go out. So I have my scales and my measures and everything. And I'm pretty much just one step short of being ready to collect my data. So any feedback would obviously be welcome as well as we talk about this today. When I was preparing my PowerPoint, I found this really cool graphic from NOAA about how easy and how many different ways there are to be involved in the idea of science or be a citizen science. And so if you're not familiar, NOAA is the National Oceanic and Atmospheric Administration, kind of maintaining the research, the data, the government organization for all of our oceans, all of our atmosphere, all of our climatological related research, which covers a broad variety of things. But if you don't think about climate change, or you don't think beyond climate change, you might say like, well, what's my space in being involved with NOAA? Or how could I be interacting with the oceans and the atmospheres in my everyday life? And it probably is a little more common and a little easier than many of us realize. So for example, if you were an animal person, like you might just like whales, you might like marine life, you might look for the dolphins when you go down the shore or whatever, and you could actually track that and take part in a citizen science project associated with that. Maybe you're just good with technology and you're really good with your smartphone, you're really good with apps. Well, many citizen science platforms are housed through those pieces of technology. And so just being able to monitor, track, and input data on a consistent basis in itself can lead to useful results from a citizen science. You can obviously do the things like advocacy that we all kind of think about a lot. Maybe you have more of a really heavy scientific interest, or you want to nerd out in biology and you want to learn something about the algal blooms, or you can track water data because you live in front of a lake or something along those lines, tracking tidal levels, or even monitoring how much debris might exist, or cleaning up that debris in a lake, a waterway, or a watershed. There's so many ways to be a citizen scientist, and it often doesn't even really have to do with the data or the research process that we think about a lot. It can help inform it. It can certainly be impactful and powerful for us as researchers to capture and collect all that useful data. But really, for many people, it's just the participatory process. There's also some other connections that people make with citizen science. Some argue that it's a method of mobilizing and democratizing scientific process, akin to how individuals do this in other areas of the democratic process. And I find this really interesting because I have this like back and forth on how much I actually believe and buy into this statement. There are some citizen science projects where I'm like, wow, I totally buy into that. I totally get how like this participation in science upholds the democratic process. It upholds how society functions and works. And then sometimes I'm like, I just don't see the direct connection to the idea of the democratic process here. And I think CoCoRaHS is one of which I don't always see the direct connection, even though I understand the connection of being an informed citizen, participating in science, and so on and so forth. So I always find this quote interesting because I use it a lot, but I don't 1000% like prescribe to it. I kind of go back and forth mentally on it. But this book was really impactful and it kind of laid a lot of groundwork of thinking about citizen science, and a lot of research articles kind of start off with a piece from Irwin to explain the importance of citizen science if you're unfamiliar. Another way to think about this, citizen science to the field of whatever specific science you're looking at, birds or algae or whatever, is very similar to public engagement to a field of politics or an issue related to political science. It's kind of our pathway to engage the general public on whatever we're talking about, to help the general public understand that concept or topic, wherever we're talking about, build some literacy, whether it's information or media or science literacy around that topic. And in many instances, this might be a better two-way pathway than having the general public just purely rely on finding information or learning through the news media or learning through social media, because that's becoming very fragmented, very difficult to find meaningful and useful information in, unless you're really, really, really literate to begin with. Why should scientists care about citizen science? Well, first and foremost, it helps us gather a lot of really useful and in many cases meaningful data. Depending on our field, this data could be really, really, really hard to collect. We take the example of weather. We would love a data point of the atmosphere everywhere we could get one. We would love one from the tip of an airplane, 45,000 feet up. We would love one at the ground. We'd love one 2 meters up. We'd love one 10 meters up. We'd love one 100 meters up. That is impossible. It's just not even with satellites, like it's just not going to ever happen. And so when we can fill in gaps with information that the general public can submit, or as these things get better, your phone can maybe automatically submit for you in terms of pressure and temperature and things like that. That can get built into our predictions, that can get built into our knowledge base of what's going on in the weather. And just get to the deeper understanding and a much more rigorous data set of what's going on in society. Sometimes it's hard to collect data because it's in a situation or a location that's hard to reach. If you take the context of risk and crisis communication, if we want to understand how somebody's doing something in the context of a weather risk or a weather crisis, it's really hard to measure that. So is there something that could allow us to maybe reach those people or get to those people in a better ethical manner? And citizen science may be one of those platforms. Maybe there's not enough collection sites, like I mentioned before, in the case of getting weather data. So the more we have, the stronger our predictions will be for the future. So we can make good predictions, you know, the forecast 3 to 5 to roughly 7 days out is pretty decent, relatively accurate. But if you go beyond that, it's haywire. It's really just climate averages. And so could we improve that? Could we actually predict 14 days out if we had double the data we had? It's a great space for you as a scientist to engage with the public. And it doesn't have to be done on TikTok or social media or some platform where maybe you're fearful of the other side or the other perspective or having to defend your work or defend your space. If people are participating in a citizen science project around your space, they're probably already pro in your favor, pro around your idea. And the last one, we've often been asked to kind of battle this two-sided perspective of being a researcher and also being an advocate for what we research and what we fight for and what we learn about. And sometimes that's a difficult thing to deal with, because if you're being an advocate for something, are you truly being neutral when you're conducting your research? Are you truly removing bias? But at the same time, how can you say, like, I'm researching sustainability, I'm researching the environment, and not practice and uphold those beliefs? So this is often brought to the table when it comes to climate scientists for a lot of meteorologists, which are really two different fields, and they're pressed to be an advocate when a significant weather event happens or some kind of disaster happens and make that connection to climate change, when scientifically, like, maybe it really isn't there, or it's so nuanced to explain, it's just not worthwhile to draw that connection. It's not a meaningful connection. What I really am interested in knowing is, why does the general public want to participate in these things? What about this process, this platform, this topic makes you feel so passionate, so interested, and so desired to be involved that you voluntarily take part? So generally, the public wants to feel involved on most issues. I think we all know this through seeing dialogues on social media about topics that have nothing to do with anybody. People just want to have an opinion in today's world. They want to feel like they can contribute something to a conversation or a space. Whether that's meaningful or whether it's maybe not all that meaningful, and it's kind of distracting. So this allows the public to actually engage in some kind of meaningful data collection, some kind of meaningful research project, some kind of rigorous process, and showcase why that process exists the way it does. So if I'm going to take part in your citizen science program and I have to record the temperature or the precipitation every day following this rigorous method, well, I would like to know why. And why does a researcher do that same thing every time? And all of a sudden I'm learning about validity and reliability and things along those lines, and replication, and just understanding the scientific method and the scientific process without even being taught it directly. I also think it leads to more interest, more passion, more exploration and learning. Maybe that's me being naive as an academic and hoping that people feel that way. But I think if you're willing to give up some of your time to be involved in a process or a practice like this, you're probably going to say, let me learn a little more about it. Let me go down that Wikipedia wormhole about this term, or whatever you do to kind of teach yourself something. it certainly helps to increase literacy. If it's a data-driven project, data literacy is an immense one, information literacy. I think in communication, some of these have communication interactions and outlets built into them, so there's even that socialization aspect and working with others. I think the ideas here are science literacy and information literacy are probably the main ones, maybe a little bit technology literacy, but probably the main ones that we would see the public get better at or increase. And then the last one, upholding that idea of normality, going back to the democratic process, like feeling as if you're a part of this process and this practice that is consistent across time and generates meaningful and consistent research because of that. Not this sporadic, chaotic research or research that's not upholding certain standards or whatever. Upholding that normality and that actual rigorous process of scientific research. And I said this before, but if you put it on the flip side, it allows the public a chance to engage with the scientists as well. So not just us reaching out to the public and having that dialogue, but in a kind of more informal and maybe not so mass media or not so mass public method, I could ask a question of the scientist, or I could ask a question of the research process, or probe like, why do you do it this way instead of this way? Or what do you do when somebody totally comes against you and goes against your science? And how do you navigate that kind of perspective that somebody might have about your project, and just engage in a little more of a informal manner or a less structured manner while also taking part in the structured research process. I think the thing that is often most taken away from many of these citizen science projects is the idea of knowledge or learning. You could call that science literacy if you want, and you're testing it on like a general science knowledge. But really what I think it does is it allows people to learn more about this space or this domain that they are participating in their citizen science project in. I think it's going to be one of the most important factors for why people choose to participate in some of these programs, whether it's eBird and Merlin, whether it's CoCoRaHS, doesn't really matter. I think people want to learn about whatever this topic is: birds, weather, recycling, trash, so on. Participants also are just naturally, in many instances, learning the best methods for what is a good environmental practice. So becoming aware of what the weather is through tracking it, and maybe over time, if you track it long enough, you realize things are changing, things are different. When I show you the CoCoRaHS interface a little bit later, there's a space for qualitative comments when people submit the precipitation reading. And one of the qualitative comments that often comes up is people who have been doing this for 10, 15, 20 years will make an anecdotal comment like, the frost was so much earlier, the last frost was so much earlier this year, or wow, the lake levels are so much lower outside my, and like making these kind of natural climatological comments that may or may not be driven by actual research, but are driven by experience of what they've seen year after year or decade after decade. And so by doing that, I think it's making you aware that like, oh, something is changing. And in many cases, probably makes you make a second connection of like, is there something I can do about that? Like I can't put my hose in the lake and bring up the lake levels again, but if I'm doing something in my shower and running the water too long, or I'm doing something that is poor behavior in my house, maybe I'm a little bit more aware of that. Maybe I research a little bit more and get better. The internet and smartphones afford us a new opportunity for engaging people and involving people in these practices. It is pretty low barrier to entry to involve somebody in a citizen science project anymore. You basically just need a very loosely coded app that can get data to a database for you, and it's functional, and that's about the limits of what you really need. It can often be done individually, but it's bringing together folks collaboratively and data collaboratively as well, which can lead to a pretty rigorous data set. And then the last one, which I always find so surprising, is so many people do these projects just purely to form a network. Just a second set of people that I can talk to about birds or weather or water or recycling, whatever it might be. There's an entire Facebook page about CoCoRaHS They're just people who talk about what they observed on weather that morning, and that's the whole page. It's like, my rain gauge has a crack in the bottom and it's leaking one tiny drip a day. What can I do to patch this up and fix it? And then, oh, look at this weird ice crystal I found on my rain gauge. And it's all they want to do is 10,000 people just nerding out about these very super specific things about the weather, and I just go through and scroll and read and enjoy it. It's kind of crazy to think about it, because I don't, even as a communication person, like the communicative component of these networks really is surprising in some cases. But then when you take a step back and think, like, you're getting a group of people who is uber passionate about some niche topic together, they're probably gonna start going and going and going with it. So it does make a little bit of sense if you decide. The second thing that I would really like to know about is what are the other motivations besides just learning? Again, you're volunteering your time, sometimes you're volunteering your space. Not everybody who does these projects is some retiree on a farm with nothing else to do with their time. I do CoCoRaHS every single morning, or my wife does CoCoRaHS every single morning. We submit something on like 300 observations a year out of the 365 days. And it's actually the consistency that's built into our schedule that affords us the ability to do it, because we do it at 7 a.m. every day before we leave for work. So like, consistency a motivator for helping people. Were you formerly in this space? Like, did you work in this space? Maybe now you're retired or you don't do it anymore, but you still want to remain connected to this space somehow. Maybe you like teaching others, teaching people about science. You're involved with scouts or something like that. And you have that natural kind of like a pro-environmental push and feeling, and you teach a lot of people, you have access to educating a lot of kids. Maybe that's why you feel motivated or inclined to be involved in something like this. Maybe you're just bored. Maybe you want a hobby and you're interested in science. You want something to draw you to the outdoors or make you appreciate what's going on outside. I don't know why I would say I take part in eBird or Merlin, whatever you want to call it, because I'm not bored. I wouldn't call like birding my hobby. I don't need something else to do. So I guess it's like it draws me to the outdoors. It makes me pay more attention to the birds that are at my feeder. And there's probably other connections, like my grandparents liked it and stuff like that. Just generally being a pro-environmental citizen, a sustainable citizen, the socialization aspect I mentioned before. And then surprisingly, people love recognition. People love that Word template certificate that you email them and says, congratulations, you did 300 things this year, check mark, gold star. People eat that up. Like, they really, really love that. There's a guy in New Jersey who I think every year has something like 360 out of 365 days observed for something like 20 years. And like, he gets an award every single year. And at this point, what does the award mean? But just wanting that recognition for being a part of the scientific process. And then if you want to make that connection to democracy, I wouldn't argue with you on it, because I think science is a mega important part of democracy, but I really think it's more like upholding the scientific method and furthering the scientific method, and a little less so directly about democracy. So before I show you one quick example, just some of the findings of what makes a strong program. The level of participation aligns with the participants' daily activity. So if you ask somebody daily to do something that takes 10 hours of their time and they're not getting anything out of it, it's just not going to work. If you're asking somebody to make a consistent observation every single day at the same exact time, and it's a reasonable time, like 7 a.m. or 5 p.m. or whatever, that's going to probably align pretty well with what participants are trying to do there. The data collection should also align with the strengths in your population. So if you're asking, say, a retired elderly person to go out to the middle of a field at 7 a.m. in the morning when it's negative 20 degrees to make their observation, probably not going to happen. If you're asking them to look out a window, take a picture of a bird, it might be a little more reasonable. So leverage the strengths of your population. The people who are willing to crawl through the mud and the marshes and collect water and data for you, they're willing to do that. Leverage them in the appropriate spaces, not in the useless spaces. And then from here, it helps you attract the participants through this alignment by having strong goals for the program, which the participants will then recognize, see, and understand how what they're doing is contributing to your research project. Kind of already talked about the social factors and the recognition. So I want to give one example. Some of you are probably familiar with this eBird, or the app is called Merlin. In 2023, some of the recognized achievements from Merlin was that we advanced the understanding of bird populations, and they actually quantified it out to 150 plus journal articles utilizing data from the eBird program, which is run out of Cornell, if you're unfamiliar with it. And they had it just shy of 1,000 journal articles leveraging this citizen science data set, large data set, all time. I think there were like 983. So they're about to be at their 1,000 published research article utilizing this data from this citizen science program. They've been able to model abundance and range maps for over 2,400 species and even make trends and predictions for how those species will change for almost 900 different species, based on the data that they have collected from people submitting observations of birds, patterns of birds, so on, how often they're seen, so on and so forth. I think the growth is pretty obvious for how successful they've been over time, whether you look at it as from observations, from reading the newsletter, or what have you. What's nice about this, though, is a lot of citizen science starts out as very like old school 90s website looking, just insert your number, hit submit, and that's all there is on the page. But when it starts to really expand and researchers recognize like this dashboard is actually useful, like if you think back to the COVID dashboards, for example, it actually forces technological development a little bit. It makes people say, people want a nicer interface. They want to submit to a platform, or they want to see their data put on a really pretty map so they can highlight where their observation is or where their home base is or whatever it might be. And it just forces us to create more useful and usable data and outputs for ourselves as researchers that they also then go and leverage and use. And again, I know I've harped on this, but the building the connection piece specific to eBird, they run a young birders event, which is basically like bird watching for teens, and they get a bunch of teenagers together and do these big bird watching programs. New York Times actually runs the summer birding event in the summer. Much else about it, but just another event to kind of promote the idea of the citizen science and the monitoring of the birds, to do all kinds of partnerships with different content partners, so environmental outlets and publications, scientific outlets and publications, international collaborators with other observatories in other countries, other universities, so on and so forth. And then informal and formal science communication with both each other. So in those communities, like those Facebook pages, the researcher to researchee kind of dialogue, and then beyond, just expanding it out into the popular media. So specific to CoCoRaHS, probably wondering what the heck does it stand for? It stands for the Community Collaborative Rain, Hail, and Snow Network. It's a nonprofit. It's run through the Colorado Climate Center. So that's housed at Colorado State. No real specific reason for Colorado other than they get crazy weather and they get a lot of flash flooding, particularly in the mountainous, like Boulder has seen some of the craziest flash flood case studies we would explore in weather. And so probably stemmed out of an event that occurred there related to those events. It began in 1998, so they just celebrated their 25th anniversary last year, which kind of started to push my idea for like a understanding of all the participants and why I want to do this research. There's volunteers in all 50 states, Canada, Puerto Rico, the Virgin Islands, and the Bahamas. So it goes beyond just 50 states, which I think is pretty cool. And every single day, there's over 10,000 daily weather observations submitted by people, regular individual citizens. I pulled the 2 data points from this morning when I was working on my presentation. Preparing for class at 8:25 this morning. There were 4,500 daily observations, which makes sense because most people at 7 a.m. will submit their observation, but the West Coast hasn't reached 7 a.m. yet. But I looked again at 10:55 when the West Coast is almost at 8 o'clock, and we're almost up to that 10,000 number. Hope that wasn't important. And this don't turn off, it's off, so that's not a good sign. So you can see, like, we're almost getting the 10,000 daily weather observations. On days when it is nice out, generally across the country, this number will be a little lower. People actually don't submit as much when there's nothing going on. And that's not good because we need to know that that actually was nothing going on and not just, I forgot to submit the weather that morning. And so people think, oh, there's no rain today, don't need to submit, I'm only gonna submit when there is rain. And that's actually not as helpful to us. We need to know the actual zeros as well. But you can see, and we're almost at that 10,000. And if you miss a day, bless you, you can capture the multi-day report, like whatever is still in your rain gauge, and just submit it as a multi-day report, which is what 125 of these people had done today. So if you're away for the weekend, you get back on Sunday, Monday morning, you submit a multi-day report for the whole weekend. It's not as useful, as rigorous because of how much longer the time period is, but it is still useful. The organization for CoCoRaHS is run at the local level through a state's climate office. So I'm most familiar with New Jersey because I worked at the state climate office there. It's run through Rutgers in New Jersey and the New Jersey State Climate Office. They would handle the local level communication. So reaching out to somebody and say like Cape May County and telling them you did something good, you did something wrong, I had a question about your data, what happened last week when the tornado rolled through, like anything, any dialogue you might have, clarifying errors, data issues. They do tons of local presentations just like this and similar to this. They do all the recognition, the printing of the certificates, and any other minor trainings that might go on throughout the year. What's really cool about CoCoRaHS is the data is used to inform current and also future weather information. So the current, meaning when you turn on the news after it snows and you see them run down a list of snowfall reports, a lot of those are CoCoRaHS submitted by CoCoRaHS observers, because at the airports, the snowfall reports aren't often as reliable. They're automatic, or you have a lot of stuff going on at the airport that can influence the weather. Like the wind patterns in an airport are often a little bit different than where they might be elsewhere, or you have a case like in Philly, where the airport's 10 miles outside the city and isn't really Philadelphia anymore. And so we can use it to inform what's going on currently, but we can also take this information and impute it into our weather models to inform future information as well. So that earlier example about how I wish we could have a data point at an infinite number of spots in the world, in the atmosphere, is because the more we can impute into a computer model for the future, the more accurate of a prediction we will get about the future. And so what causes us not to be 100% every single time on predicting the weather is the fact that we don't have a data point in every given part of the atmosphere. If there's some disturbance up there that we don't know about, or we don't have a data point for, that's going to influence everything around it. Now all of a sudden, butterfly effect, everything's different, and it just kind of cycles out of the way. So we can have more observations and leverage and use them. That's really beneficial for future weather forecasts. The home setup may or may not be a picture of my home setup in my backyard. So what you would normally do, so you take temperature observations for weather 2 meters off of the ground, because the ground can influence the temperature. So if you ever see a thermometer in an airport in one of those white boxes, they're often kind of like up here because it removes some of the ground effect of observing the weather. So we kind of try and ask that precipitation is measured about 2 meters. Now, 2 meters is high to get the rain gauge, so we allow like 1.5-ish or something like that. So it's just kind of like I think it's a 2x6 or something, and it's all it goes above the neighbor's fence there, you can see, so there's no impact from bouncing off the fence. This whole area around it, with the exception of that shed behind it, is open, so there's no trees blocking data or rain getting into the rain gauge. Wind is not blowing it out, things like that. The rain gauge can store 1 inch in this center cylinder, which fills up first. And then when you go beyond 1 inch, it overflows into the outer cylinder, which can hold up to 10 inches. So barring a hurricane or tropical storm, you almost always can capture the full amount of rainfall in 24 hours. The only example I can think of I've experienced in life would be Hurricane Irene, which was like 11 or 12 inches that you would have not been able to use. And people posted pictures of this whole entire thing overflowing in those storms because of how much rain we had received. To submit, this is the app, a picture from my phone, the app on the right-hand side. You can see it's so straightforward. The date's already preloaded for you. The time's already preloaded for you if you do it at a consistent time every day. If you have no rainfall, as you see there's nothing there, you just hit submit, you move on, you've submitted your observation for the day. If you need to change it, you put in how much rain we got, if it was a trace, or if it was something weird, and then this is where you would put it in the notes and hit submit. Snowfall is a little trickier because you can't measure snowfall in the gauge. You have to set out a whiteboard of a certain size, so far away from so many objects. It's a lot harder. You actually have to really train people how to accurately measure snowfall. You can't just stick the ruler in the ground 3 places and average it, though that's what I do when I'm trying to get the snowfall. You actually have to do it on a whiteboard and clear it every 6 hours. There's a whole rigorous process because snow will compact, so your observation's just not gonna be right after 6 hours of that snow sitting on top, or it melts, or it ices, or whatever. And so that leads to problems. So snowfall is a little trickier. This is what a map of observations looks like if you were going as the general public to find something, which isn't all that useful. These are all zeros because it hasn't rained in the Northeast. Whenever I grab this, so I pulled one from the Southeast, and you can start to see there's a little bit of difference now. You can see some pockets of, like, looking at the legend, some darker areas where they got rain in Tallahassee, and I pulled this one data point open, and they got 3.24 inches in their last 24 hours. So they had a pretty significant rainstorm. So when you pull this open, you see those 9,000 data points on the nationwide map, and how many have been submitted up to that moment. Then you can go through and explore and click on it. You can explore at the station level. So I pulled up Camden County because that's where I live in New Jersey, and you can see where they are, how long they've been doing it for, how often they do it, how often they get precipitation. A lot of really cool data just about the station, not even about the actual weather really there. From the individual level, this is my house, the station at our home in Cherry Hill, and it even gives you really cool graphical information about how often it rained at your house, where you are located, which is done by your GPS coordinates, how long you've been doing it for, how many days that you do or don't have precipitation. I actually just discovered this morning. I didn't even know all this existed, and I went in and plugged it in. I was like, I sent a Snapchat to my wife. I was like, this is really cool. I did not know this existed. And so it's forced, like, it has really forced the technology to get better, both at the observer level, at the station level, but also related to the data you're actually submitting. So what do I want to know? Do people actually learn by participating in CoCoRaHS? Do people have a higher level of science literacy or science knowledge than the general public, those who participate in these programs? Which we usually find they usually have a little higher science literacy, but that's not to say the program caused that. What are those primary motivations for participating? And then, because I'm a common media person, are there communicative or social desires or motivations for why you choose to participate? Which I think there will be for long-term participators. And do people actually care about the data, how it's used, and where it's used? And I think the answer there is going to be yes. I think people are going to start to care more and more as some of us start to care more and more about privacy. I think people will treat data that they are submitting, that they are, like, kind of not claiming ownership of, but kind of putting their name behind. I think they are going to start caring. If that's used for the wrong purposes, it's not going to be seen as beneficial. I just have 2 slides of 2 scales. I'm not going to read them all to you because I want to save 10 minutes for Q&A, but the one scale is just a pure motivation for volunteering scale, which is drawn from a water quality scale. So the citizen science project they used it on was related to water quality. So just I'll amend it very subtly to be weather overall specific. And then the second one, the communication, the social aspect, which will be really important to me being a comm and media person. So yeah, that is kind of a little bit about my citizen science and citizen science project in a nutshell. And I'd love to talk more about it or take any questions. Thank you.
Like the sort of aspect within CoCoRaHS, like it's an app, is there like posting, is there commenting on that stuff?
Yeah, so within the website/app, just that one box for like you to submit qualitative comments that you could then go and find somebody's station and see what they've observed, see what they've written. What really happens more is that Facebook page, I don't know, it has maybe like 10,000 members, 20,000 members or whatever. It has people who do it, people who used to do it, or like alumni of the program. It has like the state climatologists will join, like researchers will join, like almost everybody who has interest in this can join that. Ask questions, answer problems, and like do anything related to dialogue on this program. which I think is cool, because it makes that a community that's separate from the program that allows for more communication, like it could be technical issues you're having at home, or it could be like, I wanna get involved, but I don't know about the time commitment, like a general question like that. It really allows just for like a general, it's almost like the epitome of what a Facebook group really is. It's just like this general cacophony of all kinds of stuff, kind of centered around a topic. So I don't know that everybody participates in it. That would be the tricky part. Like I'd have to almost have a secondary piece of the survey. It was like, do you know about the Facebook page? And if so, then move to these questions. Or is there another way you communicate with people? People like, it's weird. So people, when they comment, they put their station ID first. It's like, it's very like military. I don't know. It's very strange. It's like NJCM 39, and then they write their actual comment. So like they identify who they are based on their station first, and then write whatever they're gonna write, which is just, it's weird, but you get used to it. So people like take ownership of it and where they're from and everything like that, which is kind of cool. So yeah.
Similar to, ground observation and how they can be used for any kind of
Yeah.
research. Can the data that gives, like, say, climate geographer wanted to extract a spatial file, could that be, like, is that kind of data able to be used, like, just available?
Yep. Yeah, super easy to do. Yep, exactly. So you could go in, you could pull it, probably as a CSV or some other file better for your geo programs. And then trying to think, like, so one example study is you could compare a CoCoRaHS site, like say you wanted to compare my Cherry Hill site to what happens at the airport, because they're 8 miles apart, just to see if there's a significant difference over time. The airport will have the NOAA record from all the way back to the 1900s or whatever, and then you'll have this data from however long it's been observed for, probably not 25 years at most, but probably most people haven't been doing it that long. You could make a comparison of like, is there any difference between these two data sites? Is there climate change evidence in one versus the other, something like that? Absolutely. It would just be purely focused on precipitation and snowfall and things like that, not temperature in this case.
Yeah.
But then you could align it with other data points to do it there. Yeah. Yeah, it's a great question. That was, I used to QC the data. That was my job. I would go in and we'd see, oh, somebody reported 95 in the middle of December, and you would have to identify, flag it, and then argue for or against if it was a real data point or it was accident, which was very, very tedious. It was manual done, so it was not fun. Yeah.
Yeah, I was just curious, for your city, how you're gonna go about recruiting participants, where you're looking to get those.
Yeah, so I originally was gonna do this as a 2-part study, I think I'm just gonna lump it all into one. The person at Rutgers, the state climatologist in New Jersey, he's been a state climatologist since 1993 or something like that. So, he's best friends with all the Colorado State folks, they have really good partnership on. New Jersey is almost like a case study, great example of CoCoRaHS. Some states like Delaware don't do it as well. And so with those connections, we can send it out in the newsletter, the recruitment message, and the CoCoRaHS newsletter and stuff like that. So just direct message to people who will be the participants. And we expect, because it's people who are already volunteering their time for a citizen science project, we probably get a good response rate. Although I did read in one of the studies I was reading this morning, that you have to be cognizant of the fact that you're probably only gonna get the upper half of the people who have been doing it the most and have been the longest, and those are probably the people who are gonna respond to your surveys, not the new people and such as much, so you might be skewed towards those veterans, we'll call them, or something like that, but yeah. Access is not too much of a concern here for me. I think I'll be able to get it.
Are you looking at New Jersey, or are you going?
I'm going nationwide. I was originally going to do it around, so state level doesn't really make sense, because we get our weather information from National Weather Service forecast offices, which are not at the state level, like all that. So I was gonna do it by forecast office, so Mount Holly, Philadelphia for us. But I don't really think I'm gonna find anything all that different for this region versus, say, the Midwest. So I think I'm just gonna run a nationwide, gather the data, and then there's a follow-up,
And do you know of any citizen science clubs that actually meet in person, that are using online apps?
That's a good question. I don't know of any. I would be willing to bet there are sub-communities within this group, like So weather and military is often very connected, and so like retired Air Force meteorologists who now do CoCoRaHS, like I'd be willing to bet there's a gaggle of them somewhere in that Facebook page who get together in person, who are close geographically or in the same state or something like that. Just as any of us would for a car or sports team or something, I'm willing to bet, knowing how people get about weather, that there are probably subsets that do that.
And I'm also picturing there may be people who are also members of a bird town and that use eBird.
We have a lot of Christian science, kind of, unfortunately it still is, like, it's through email, not social media, but like, I see like a lot of Merlin, just other stuff like that, like, they send them out through subscription email, but then you get all the other.
Yeah. And I think what's really cool is seeing how many of these programs took off during COVID, and like how we were stuck at home and we wanted other things to do to get our minds off of COVID or work, which was now at home with us. And so like, we were like, let's look at the birds, let's track the weather, let's do something else that just gets our mind off of it. And so they're even amidst like arguing one of the most chaotic times of our lives, people are willing to make that jump to do something and engage in something like this. So I still think there is an untapped space, whether it's at the K-12 like education level, or it's here at college or whatever, for getting people involved or exposed to more of these projects. A lot of CoCoRaHS observers are schools, because it's so easy for that person to rise at 7 a.m. every day to unlock the door to take that observation. And you can talk about it in the science class, you can talk about it in a statistics class, so, and it's $40 for a ring gauge and $5 for Visa Wood. So, it's pretty low cost, low barrier to entry for schools. A lot of places will partner with the weather bug camera and put it next to the camera, so when you see the camera, you're seeing what's just going into the gauge kind of. So, yeah.
I have two questions.
Yeah,
We're not quite to 12:50 yet. We always pause at 12:50 in case folks have to get off to a class, but my first question should be pretty straightforward. CoCoRaHS, you mentioned, is the community collaborative rain, hail, and snow network.
Correct.
You talked about the challenge of measuring snow, and you talked about measuring rain. How do you measure hail?
That's a good question. So you don't really measure, well, okay, that's true. You don't measure the quantity that falls of hail. You measure the size of the largest stone you find. And I forget the exact process, but there's a way, I think you measure it, the full way across. So the full diameter. Yeah, so you measure the full diameter across and submit that. And often when you submit it, you'll submit it with some other object of scale to just prove you didn't manipulate or whatever. So hail's cool because hail falls and then it gets shot back up into the thunderstorm, and it falls again and it gets shot back up into the thunderstorm. So that's why hailstones aren't usually round. They're actually falling down, hitting all the raindrops and making all these weird shapes. And then the updrafts that thunderstorms have are shooting them back up and they fall back down. So the ones that get the largest are making that up, down a lot. And they're not making it to the ground until they hit their critical mass and finally fall out of the sky. And so there's hailstones all the time in thunderstorms, never make it to the ground, or they melt on the way down or something like that. So when a liquid is super cooled, it'll hit those other raindrops and they'll all coalesce together. And that's why we get those weird non-round shapes. So sometimes it's hard to measure because it'll be like a figure 8 or something like that. Two big hailstones ended up merging together. But yeah, I think that some of the biggest ones I've seen have been grapefruit size. Not here, but like I've seen pictures of grapefruit was probably the biggest I've seen.
Right.
No thanks.
Cool. My other question has to do with your background, because the way you described how you got to being the PI on this project shows that you've got familiarity with the hard sciences, with the social sciences, with the humanities.
Yes.
I wonder, how does that give you, I wouldn't say unique, there are other people who have this background too, but that's a lot of different perspectives at which you're coming at this. I'm wondering how that has shaped your research question.
Yeah, it definitely has. And having my wife still be in the physical science and hearing conversations that happen adjacently or happen in a lab and no lab or whatever, sometimes it makes my head like tick a little bit. And so like, it's cool to still be able to see that like true physical science perspective and compare it to like what's different in life now for me. One area I think it is immensely powerful is the ability to explain statistics. So understanding statistics is one thing. Statisticians understand statistics and the equations and yada, yada, yada. But explaining statistics to people in an understandable way is very different. I don't know if anyone in here has ever read the book, I think it's Wicked Statistics, which uses all these like real life examples to explain t-tests and means and all these different things, like batting averages in baseball and economic, like job, unemployment rate that you hear in the news, and like real life examples to explain the concepts that we learn in a research methods class or whatever. And I think that is where a lot of physical scientists can get lost and stuck. They probably understand so much statistics, so much calc force, so much math and quantitative information, but getting it to people in a form that is digestible is hard. Like digestible is one thing, then taking it a step further and like collaborating and helping them understand is another thing. Like we hear it a lot in the 1 in 1,000 year storm. So it rained so much, it was a 1 in 100 or 1 in 1,000 year storm. That's great. It's kind of quantifiable. You kind of understand like, oh, this only happens once every 100 years or whatever. Until 3 weeks later, it happens again. And you have two really extreme events so close together that people are like, whoa, wait a second. I thought this was once every 100 years and we just had 2 in 1 week. And like, oh, that's climate. And like, they just try and make the explanations that aren't really there or try and draw the connections without understanding the background. I think that has been immensely helpful in a lot of cases. Like I don't care about going mega advanced on statistics. Like I would rather go surface level and people understand it, general public understand it. Like I understand the research standpoint, but like we have to help society, we have to help the general public here. The humanities thing is interesting because so many people dismiss art, humanities, and the science, and there's such a good connection. And so many people understand science through art way better than they understand it any other way. Like whether it's that artistic creation of all the piles of trash or the recycled goods, or whether it is actually a data visualization or whatever it might be, some people just understand and interpret things that way. And we have to understand and recognize that and play into that. And I never would have, like being a physical scientist, I would have thought, that's correct. I never would have ever adopted that mentality. And now going to a college of liberal arts at CUCON, and then like being in arts and humanities here and seeing so many people in so many spaces do this work in different ways, I'm like, oh yeah, that makes a lot of sense now. And I totally understand that amongst qualitative versus quantitative and how people might interpret that differently. And so I think it's just made me understand more generally the differences in methods and how they're similar across fields, but they are still very different. And understanding a little about each of those, I think is very helpful in trying to explain them to different populations. I don't know, maybe it was a little bit of the journalism background was helpful. Not sure, I don't have an answer.
Sounds like it all.
Yeah,
Great.
I just enjoy it, like I just enjoy science generally, obviously, so that helps.
Well, thank you very much. This has been.
Thank you.